So hi guys, hope you all are doing great and the course is also moving in a great manner. So today we'll be covering the next topic post prompt engineering, that is nothing but document search. So document search is not a difficult topic, it is a relatively easier topic, but these would be the guiding lines or the setting lines or perhaps the main foundation that we are going to lay up in order to create some real time excellent use cases. But this sort of foundation is very important. So essentially, let me just try to insert one shape, and let's just talk a bit about document search. Okay, let's just talk about document search. So see guys, the word actually is self-explanatory. Okay, right now I'm not mentioning any fancy word like RAG, but yeah, we'll come to RAG and everything as well slowly, but just try to understand that what we are discussing is document search. So let's say we have a document. Okay, now the document for this discussion that we'll be considering is my CV. Let's just consider my CV because for the time being I don't have any great other thing, so let's just stick to this only. Okay, now this is our document. So in companies there are so many documents regarding anything, right? Every department will have their own document. So first of all, let's try to do one thing. Let's just try to upload it. Okay. So essentially, whenever you will be doing document search, you need to upload your document to a storage location. For the time being, I'm using Google Colab storage only. That is fine. Okay. So the next thing is, what is the problem? So what is the document? Document is my personal CV. Okay. Now any LLM on earth wouldn't know anything about my CV, right? How it would know that what work I have done and which organizations I have worked, what is my college percentage? It wouldn't know, right? So when you want an answer, okay, you want an answer that is LLM generated, but the data source has to be your own. In that kind of a scenario, we are essentially doing document search. So see, the idea is we have a document. The document is any document which is there in your organization or your personal document, and you want to create a system, you want to create a chat bot that would respond to queries based on that document. Now the thing is, we talk about things like, let's say, customer support. Now, any chatbot can't answer customer support queries in context to all organizations, right? Let's say organization A has a policy of resolving a ticket in 6 hours. Organization B has a policy of resolving the ticket in 12 hours. So we can't just throw up things on the air, right? We need to have some document base. So essentially, document search is an idea where you are asking your LLM, hey, you got to answer these queries, but the context that you would be questioning would be essentially from the document that I provide to you. I think you would have understood. So now we have uploaded our document. The next thing is, let's just install few libraries. So we are doing Google Generative AI in this course a lot of time. I think most of the times we are using Google Generative AI only. Then we have PyPDF. So we need some library that will help me extract text from document. And then we have LangChain community. Okay, so LangChain community is nothing, it is just a module of LangChain only. If you would Google and type LangChain community GitHub, yeah, you can just do it if you would go to LangChain. So this is an open source framework that we have been using in our course, and yeah, it's just opening. So yeah, we are using this, we'll be using that to do some stuff. So if you'll go to libs, see, you have community, right? So you have community, see, you have LangChain community. So this is how you can see everything you can see, okay, in GitHub if you want to go into that depth. So we are good till here. Then we are importing sub libraries, nothing, NumPy, pandas, and Google Colab user data. So this will essentially help us fetch API key. So now I'm using my API key of Gemini. I in this course have shown again and again on how to generate one and how to use that. So now let's just try to see what is this cell doing. So now this cell is giving me the embedding models of Google. Okay, now I have used one word. Let's just try to discuss over that as well. I have used a word that is embedding. Embedding. So see guys, whenever you have text, that text needs to be converted into numerical vectors. And once your text is essentially converted to numerical vectors, that process is known as embedding. Okay. The idea is that my model, any mathematical model, especially LLMs, on the base LLMs are nothing but there are neural nets. Then we can discuss that, hey, we are using transformers, hey, we are using attention, we are using vision transformers, but essentially it's a neural net, right? So in a neural net you have multiplication, matrix multiplication, in back propagation you have a lot of calculation going on, essentially gradient optimization and stuff. For that you need numbers and essentially you need vectors. So the idea of converting your text into vectors is known as embeddings. uh, Hopefully we'll have a detailed class on embeddings as well, but yeah, for the time being this much knowledge is fine. So these are embedding models. So using these embedding models we can convert our text into vectors. Good. So now what we are doing essentially is, let me just rename this file first. Let me just rename it to cb.pdf. Okay, yeah. So LangChain community.document loader spy PDF loader. So this code is helping me extract text from the PDF that we have. This is the power of LangChain, guys. So in the entire course I have been explaining you how we are using LangChain, right? So see, there is document loaders, and inside document loaders what are we importing is, we are importing py PDF loader, py PDF loader, py. Yeah, so it would be somewhere here only in the document loaders only. So yeah, so we are importing py PDF loader. Okay, so the idea is that because of LangChain, only in these 3 lines of code you are able to extract text from a PDF. Isn't that amazing? So let's just run this. So that is why, guys, this is a framework. This has a lot of high level functions that we would use directly. Okay, now let's just see what is inside pages as well, so that you can visualize things in a better way. So what we have done is that we have extracted all the information from my resume, whatever was there. Now we are defining a model, Gemini 1.5 Flash. Okay, now see again, guys, in the last class we have seen a lot of prompt engineering. Why are we doing this? See guys, if you would go to the documentation, this is document search and this is by Google. Okay, the thing is, in order to do things in a crystal clear manner, Google recommends that we should have our data set in this format. Okay, so in every chunk, in every piece, there should be, you have a document. That document has a lot of text. The text needs to be splitted into multiple sections such that there is something known as title, and based on that title there is something known as text. So in my resume there is Aditya Bhatt profile. Aditya Bhatt does this. So see, it has broken down, and now I'll show you how did I do it. Right now we have just extracted the text from PDF. Now I am asking an LLM to provide me data in this format. See, this is the prompt that I have written. Act as a teacher who is great at formulating text-based information based on a set of data. This is the given data. Convert it into this format. So it is able to convert it into this format. Okay, let's just try to run the prompt. Let's just try to query the model. So see guys, here we had a task of data manipulation, right? I didn't have the data in this format, right, where it is document title and content. This is the format that is required to convert into embeddings in a simpler fashion. But I had a random PDF, so we took a PDF, extracted text using LangChain, and LangChain is essentially using PyPDF. Then at the third layer, we are asking our LLM to convert this random so much information into this format. Now if I print the result that we have got, see, it is able to extract a lot of relevant information, right, regarding my resume. So what we'll do is we'll just try to copy this from here to here, Control C, and then we'll paste it, Control V. So see, we are able to get the data in this title and content form. Right now I've just kept it 10 rows. You can make it 30, 40. However, this is just for demo purposes. Okay. The only question someone might feel is, why are we doing this step? See guys, until unless our data is not in a specific format, we cannot do anything. This is the format that is suggested by Google. So we are converting our data into this format using an LLM, using this prompt. Okay. We are good till here using this prompt. Okay. In prompt engineering classes I have shown you, this is a simple prompt, but just try to see the idea of how we are using. We had a PDF, we converted text from that PDF, then we are from that random text we are able to generate a good looking table as well. Okay, let's just convert it into a data frame. Documents is not defined. So see, we have this text. Now this code is essentially helping me convert my text into embeddings. Okay, now you will see vectors. So as I said, you have text and you want it to be getting converted into embedding. See, it got converted into embeddings, right? These are embeddings, these are numbers, right? See, these are words, and these words are getting converted into numbers. Okay, numbers are nothing, numbers are vectors. I think we are clear over here. And now some of you might ask that, hey sir, from where we can get this code and all. Guys, see, this is given in the Google documentation. From there only I have directly used, so there is nothing so great about it. Okay, now see what we are doing. Now we are asking the model a question, who is Aditya Bhatt? Okay, and this is the embedding model that we are using, and we are just creating a request. Okay, that is okay, nothing great. Now what we are doing is that we are writing a prompt and telling the model that, hey, you need to answer based on the reference. Read it. You're a helpful and informative bot. Be sure to respond in a complete sense, including all relevant background information. Okay, what is the relevant passage? The relevant passage is the passage that is from your document. So essentially we are fetching that over here. Okay, then what we are doing is we are finding the best passage. So what essentially is happening over here in this piece of code is, first of all, I'm defining a prompt. What I'm telling the model, I'm telling the model that you need to answer a question, but you need to answer it from the reference passage that is provided to you. Okay, now the question you will ask me, what is reference passage? Reference passage is the best passage from the document. Okay, now the thing is, what is Aditya? But I think I'll run it and you will understand. Okay, now what is this Python function doing? Find best passage. So it is basically trying to convert dot product of my embeddings, okay, and my query embedding. Let's just see what is query embedding. Query embedding is nothing, just it is trying to convert my query into vector. So what is happening? My query is being converted into vectors, and then based on that, the query, what is my query? Query is nothing, who is Aditya Bhatt? So based on this, it will compute dot product with all these embeddings, and it will find the most similar one. So see guys, I think you would have known what is cosine similarity. Let's just write dot product. Okay, let's just see any images. So see, this is the dot product. Okay, so essentially what we are doing is we are converting, or we are computing similarity between this vector. Which vector? Query vector. What is query vector? Who is Aditya Bhatt? and then we are comparing it with the embeddings that is being generated over here. I think it is clear. Then we are finding the best passage. That means we are finding in the thing that we are finding that portion of the text which has the best similarity or the highest similarity in terms of dot products with my query, and then we are just passing into the model the prompt and query, and then we are generating the answer. So you are able to see it was able to tell many technical skills, programming, machine learning, person, background, profession, anything else about it. Yeah, so actually it was not able to extract the document information very well. So maybe you can increase the documentation frequency to more than 10, or perhaps play around with the prompt or rerun the script. Something better is going to happen. Okay. So guys, see, in this project what we essentially did is, let me explain you. So first of all, we had a PDF. We extracted text. Then we told an LLM to give us important information in a format. Okay. We converted that format into a data frame. We passed the text in those data frame and got embeddings. And then our query got converted into embeddings. Then between query and data frame, similarity was compared row by row. We got the row which has the highest similarity, and then along with the highest similarity row, along with the highest similar row plus my query went to the LLM, and based on that it was able to generate an answer. Okay, this is RAG only, but yeah, we'll discuss RAG in a separate class, but this is more of an idea of how you can chat with your own documents. Okay, in this video you were able to see you had a PDF, we extracted text, we did a lot of stuff, we created into a data frame, and then based on those data frames we got the embeddings, and from the based on these embeddings we are comparing the dot product with the embeddings and my query. Then the most this is the passage that is being computed, that is the most relevant thing, and that relevant thing is being passed to the model to answer. That's it. See, this prompt is equal to make prompt and prompt. So guys, just go through this notebook. This is very simple, you will understand. Also, if you have any doubts you can DM me on LinkedIn or Instagram. Okay, so thank you guys.